Hello there, it's for Year 12 Maths now. We're going to look at some more binomial expressions, sometimes called binomial expansions. And you'll notice I've got an example here, and it says a plus b to the 5. Of course, we were looking at this last time. This is our second look at it. A plus b to the 5. Notice how to get the coefficients, you go to the fifth row. Doesn't count the top one. It's the one with a 5 in. So 1, 5, 10, 10, 5, 1 are my numbers. And each time you put those numbers in, each time the first power goes down, whereas the second number goes up. And that's basically what we're trying to do. So I've got a few questions for us here. Note first of all that there is a formula, posh formula for this. And this is actually one way of thinking about it, because these, what I've called binomial coefficients, these can come from the calculator, and you can press the NCR button on your calculator, which of course is above the divide key on the Casio class Wiz, and you can pinpoint a particular one. So if you want, I don't know, n is 14 for instance, and you don't really want to draw down to the 14th row of the Pascal's triangle, you can just type in 14C2 for instance, and it would tell you what this value is. So this formula is given in the exam paper, so you don't need to learn it as such, but it's useful if you know it. The first question then, it says write out the first 5 terms of an expansion of 3x plus 2 over x. Now, these fractional ones can cause problems. So whenever there's fractions, it can cause us a few problems. And notice I've actually written out the 7th row of Pascal's triangle down here. If you drew out Pascal's triangle, these would be the coefficients. So now we know those numbers, we can just use them. So it's, also it says the first 5 terms. So sometimes, rather than saying write out all the terms, because they know that can take forever, and they don't have forever in an exam, sometimes they give you a specific number of terms to write out. This one does say that, first 5 terms. So my first number is 1 times by the first thing, which is 3x, to the, now notice 3x, there's 2 parts to it, but I've got to raise it to the 7. So I put it in the bracket. Times by 2 over x to the 0. Now, again, I have no problem if you miss this bit out, because 2 over x to the 0, anything to the 0 is 1, makes no difference. Now, it's a plus in the middle, so all of my terms will be pluses. Next one is 7 times by, in brackets, 3x to the 6 times 2 over x. Plus, what's the next number? 21 times 3x to the 5 times 2 over x squared. And again, notice how 2 and 5 make 7, 6 and 1 make 7, 7 and 0 make 7. That will always be the case if they add up. I think we've seen that before. This is my 5th term, 1, 2, 3, no, this is my 4th term. 3x to the 4 times 2 over x to the 3. And my next one is, I've used one of my 35s, I've got another 35 down there. So 35, 3x cubed times 2 over x to the 4. And that's a case of simplifying. 3 to the 7, it's not something you know off the top of your head usually, so I'm going to type it in. 3 to the power of 7. 2187. After a while actually you do get to know these, but 2187 x to the 7, so that I basically raise both bits to the 7. This disappears. Plus, well, 3 to the 6 is obviously 729. I say obviously, I'll just did it on my calculator. Times by the 7 times by the 2. So times by 14 equals 10,206. You get big numbers sometimes on these. Now notice here, this is going to be x to the 6. So I'm going to get x to the 6. But then I'm dividing by x. Now that effectively gives me x to the 5. Notice how it's gone down. Rather than normally it goes down 1 power each time, this time it's gone down 2 powers. Next one, I've got 21 times 3 to the 5 times 2 squared. So 21 times 3 to the 5 times 2 squared. I get 20,412. Even bigger these numbers. 20,412. And again, this will give me x to the 5, and I'm dividing now by x squared, which will be x cubed. And notice again it's gone down in 2's. So that will carry on. It will always go down in 2's on this question. The next one is 35 times 3 to the power of 4. And not only that, I also need to do the 2 cubed. And I got 22,680. And I can tell you now it will be x to the 1. Lastly, I've got 35 times 3 cubed times 2 to the 4. Right, 15,120. Now this one is, you can write it x to the minus 1. It's gone down 2 more powers. Or you could write it over x as well. It means the same thing. And that's my first 5 terms. And notice how this one I did write 15120 over x, which is the same as this. Everything else I'm going to guess is the same. Yes, it does look the same. Write out the expression of this. Now, the expansion of this. So this time it wants the whole thing. The 5th line is there, so I can just write 1 times by the first thing to the power of 5. I'm going to miss out the other bit. Well, notice it's got a minus in it though, so it's going to go plus minus plus minus. Minus 5 times 5y to the 4 times by 2x squared. Plus, it's going to be 10 times 5y cubed times by 2x squared. Oh, that's going to potentially cause us, it's not hard, but just, be careful. 10 lots of 5y squared, 2x squared cubed, plus 5 lots of 5y, now to the 1, 2x squared to the 4, plus 1 lot of, 5y to the 0, I'm not going to bother with, 2x squared to the 5. So, what's this equal? 5 to the 5. 5 to the power of 5 on my calculator, 3125. Notice it's not just the 5 that's raised to the 5, it's the y as well. 315, 125, y to the 5. Minus 5 times 5 to the 4 times 2. So I think that is double what I had before. I think that's minus 6250. Now notice now I've got a y to the 4, but I've also got an x squared. So, well, which way around to put it? Alphabetically, x squared, y to the 4. Plus this time, I've got 10 times by 5 cubed times by 2 squared. I get 5,000, so notice you have to do both of those. So plus 5,000. Now, x squared has got to be squared. That's x to the 4. Y cubed. This time it's a minus. 10 times 5 squared times by 2 cubed. And I get 2,000. So again, 5 squared, 2 cubed. That's where people go wrong on these. This is 2,000. Now x squared has also got to be cubed. So that's x to the 6. Y squared. Plus 5 times 5 is 25. Times by what is effectively 16. That's 400. That's a plus 400. Now it's x to the 8. Now I just spotted this next one should be a minus, but I wrote here plus. That was a silly mistake. 2 to the 5 is 32. And x to the 10. Oh, I missed out my y here as well. That had a y there. So a couple of dodgy near errors there. Interestingly, I wrote my y's first every time. Didn't matter. Makes no difference. Just looking at the numbers. Yes, they look as if I agree on my numbers. Find the coefficient of x to the 4 term in this expansion. Oh, right. Now, this is a specific term it wants. It's in the expansion. Well, for a start, my Pascal's triangle there doesn't go down far enough. So, because I want this number, I want 12C4. Technically, I actually want 12C8 because it would be the 8th term that gets me to it, but by symmetry that will work as well. So 12C4 or 12C8 doesn't really matter, but it's going to be times by. Now I want x to be to the power of 4, and so my rule has always said you add the two powers together to give you the total power. So that's 2 to the 8 there. So I'm just going to type in 12C4. I can honestly say I've got no idea what 12C4 is. 12C4 equals 495. And there you see, you do well to remember that. Times by 2 to the 8. Now, 2 to the power of 8 is 256. So you're going to end up with a big old number of x to the 4. So together, yeah, here's a big old number, 126720 x to the 4. That's the coefficient then, is 126720. 126720, that's right. Examples, and we've seen this already, where it says minus in the middle. I've already said you go plus minus, so just be aware of that. So here's one, it says simplify and find the first 4 terms of this expansion. Now again, to do this I need 18C0, which I know is 1. I need 18C1, which I know is 18. The next two, 18C2 and 18C3, I haven't got a clue what they are. So I'm just going to do those now. 18C2 is 153. And 18C3 is 816. So the calculator button comes in very handy on these. So I want the first 4 terms of this. So it's 1 times by... Now when it's 1 at the front, it's the best thing ever, because 1 to the 1 is just 1. So effectively, you can just ignore the 1. And I'm going to end up with, well, it's just going to be 1 times by the x to the 0. Minus, because it's a minus in the middle, it will be 18 times by x to the 1. This comes out brilliant, this. Plus 153 times by x squared. And this all becomes easy because of this 1 at the front. 1 to the anything. So if I'd written 1 in there, it wouldn't have made any difference. Minus 816 x cubed. I actually think that's the answer. Yeah, there you go. Okay. Another fractional one. Fractions always cause us a few problems. And it says as far as up to the x squared term. So the 8th one, I'll just ping those numbers up. And there they are. I've just done those in the calculator. So my first term here will be 1 times by the first thing times by the second thing to the 0. There it's a minus, so it's minus 8 times 2 to the 7 times by a quarter x to the 1. It says go up until the x squared term. Well, presumably that would give me an x term. Oh, I think I only need one more of these. Plus 56 times by 2 to the 6 times by a quarter x squared. 2 to the 8. Is that the 256 one? Yep. Minus, now it's 8 times 2 to the 7 times by a quarter to the 1. Quarter to the 1 I can just think of as a quarter. 8 times 2 to the 7 times by a quarter is 256 again. That's 256x. And then the next one, I think which is the last one, it's 56 times 2 to the 6. And I've got to do a quarter squared, which is effectively like a 16th times by a quarter squared. I get 224. 224x squared. And I think it said up to the term in x squared, and I've got up to the x squared term, so I think that's it. Yes, it is. That's right, perfect. Oh, I've already got the answers on this one at the bottom. Write down the coefficients of x to the 4 and x to the 6. Well, first thing to notice on this is, because it's x squared, I think the first one, and it's to the 7, which is 1, 7, 21, 35, etc. So I suppose if I was going to do this, I'd know that the first term would give me x to the 0, the second term would give me x squared. I think I need that one. I think I need 21 times by, well, it's going to be x squared has got to be squared, which means the 4 has got to be to the power 5. And the next one will be the 35 times 4 to the 4 x squared cubed, and that will give me the x to the 6 term. So just check those, make sure they work, and get the answers at the bottom. Now look, I've run out of time. Well, that's good timing, because that was the last question. We in class will finish off exercise 9A. We did some of this last time, and I want to finish it this time, so that hopefully we can do it all in 2 lessons. I know there's a lot to do though. So best luck.